Yeah, that looks like a good one.
Yeah, this is a bit of a doozy.
Yeah, all right.
Okay, so here we go. Let's just dive in. Again, we're collecting evidence like Sherlock Holmes so that we can sketch this thing. So these are some good clues that will give us an idea of what this looks like. X-intercept, remember that's where it crosses the x-axis, where y equals 0. We're going to get good at this, so I'm just going to say, when does this function equal 0? For those of you who love algebra, you could solve this by multiplying both sides of the equation by that denominator, or you can make that leap of logic that Mr. Haas was talking about. Any fraction with 0 on the numerator is going to equal 0.
Yeah.
You know, you can't get a 0 out of the denominator. So I'm just going to set that numerator equal to 0. And again, lots of times we factor to help us find out what those zeros are. And I think hey, look, it's a perfect square.
Well, that's interesting.
Cool. That is interesting. So what x is going to produce a 0 up there, Mr. Haas?
Well, -2 and -2. Ooh, let's keep track of that. That's like
a double root.
That is like a double root, exactly the same as when we did the polynomial sketching. That root is double. That's twice. All right.
That is a double root.
Interesting.
So we might be doing some bouncing.
That's what I asked. I'm thinking we are.
I'm just going to rewrite this.
That is a double root.
Okay. Y-intercept is when we now want to plug in. I guess I don't need that right now. We want to plug in 0 for x, because that's where it crosses the y-axis. And what is the value of x when we're touching the y-axis?
Yeah.
0. Okay,
sure.
so here I go. 0 squared plus 4 times 0 plus 4. 0 cubed plus 3 times 0. Hold on! Quick, the math police are going to arrest us. What am I trying to do?
You can't divide by 0. That's crazy.
Divide by 0? Well, what the heck does that mean for
so
y-intercept?
there is no y-intercept.
Oh, okay. So this does not cross the y-axis. Because that's nonsense. That doesn't make any sense.
Just to be clear, again, and this comes up, again, you know, if this is one of those things you've got to get in your head. 0 on top, that's 0. 0 on the bottom, undefined.
And if you think about it for a little bit of time, it makes sense.
But it's a thing that sometimes students get mixed up. You have to say it to yourself. Are you saying it?
I'm saying it.
All right, good.
Okay, let's go to horizontal asymptote. Horizontal asymptote, of course, is our end behavior. Where does this guy go when my x is getting really, really big and when my x is approaching negative infinity? Positive infinity, negative infinity. Mr. Haas, you did a nice job of this before when you were looking at your controlling terms.
Yeah, right? I think this is just going to be another 0 case, isn't it?
I think it is.
Sure.
Your denominator is a heck of a lot bigger than your numerator. I think we're just going to be approaching 0. All right, so I've got a horizontal asymptote. Hey, I crossed this horizontal asymptote too.
So now, wait a second here. Now, what if, I never know, like, when do you, sometimes you can just look at the exponent, and sometimes you have to look at the coefficients or something. Is that how that works with the horizontal asymptotes?
Yeah, well, here, I'm looking here, and we can do what you did. Let's actually divide my controlling terms. That gives me 1 over x. That's 1 over 100, which is 0.01. 1 over a million,
but
which
like,
is 0.00.
what if there had been like a coefficient? What if it had been like, I don't know, 7x squared over 2x cubed or something? Would that make a difference?
Then you'd end up with 7 over 2x.
Oh, so as long as the exponent is bigger on the bottom. Right. All right.
You're right. It's the exponent. As long as the exponent is bigger on the bottom, think about it. That's what's making it really, really, really huge.
Got it. Right. Thanks.
All right. So now, vertical asymptote, that's all I need. And vertical asymptotes happen at those places when my denominator equals 0. Well, we already discovered one of them. Where do I know I have a vertical asymptote? At the y-axis. But let's be formal about it. Let's factor that denominator. Looks like there's a greatest common factor of x squared, leaving me with x plus 3. I'm just going to put the numerator up there in factor form just for the heck of it. So that's
your 0 right there.
That's my 0.
Yeah.
A 0 produces 0 in the whole denominator, and a -3 is going to produce a 0 1, 2, 3. So I have a a vertical asymptote at -3 and at 0.
So, Ms. Stewart, you know, would it ever be possible to have a vertical asymptote at the same place that you have your x-intercept? You know what I'm saying? Because sometimes students
know
like
what
will
you're
get
saying.
that, and it's like, well, I wonder there.
Yeah.
You know what I'm saying? Like
what you're saying.
you have an x-intercept of -2. Could it be possible to have a vertical asymptote there?
Absolutely inconceivable.
Why is that?
Well, because the vertical asymptotes are when the function is undefined.
That's right.
When
That's
it doesn't
right.
exist.
That's right. So you
So you can't have any point there.
Right. You can never cross the
You
vertical
can
asymptote.
never cross a vertical asymptote. It's a hole in that function.
Horizontal asymptotes you can cross.
Yeah, because
Okay.
horizontal asymptotes just tells me what happens off the page.
I think we've
if
said
you
that
will.
before, haven't we?
Yes, but
All
let's
right.
say it again
Okay.
and again. All right, wow. I don't have much to go by here. I think I'm going to have to plug in some points. And that's why, Mr. Haas, I left that factored, because sometimes doing sign
Yes.
analysis, especially because you folks out there don't have your calculators, sometimes it's handy to use your factored form when you're doing
Oh
sign
yeah.
analysis.
Yeah.
Okay?
Way easier.
So, can I erase this and
Absolutely.
put all that there? All right, so I'm going to have to plug in some points to see what's going on. All right, let's start down here, shall we?
Let's pick -10. What the hell? I like
You're into
big
-10.
ones. Oh yeah, I'm gonna pick +10
All
too
right,
if you give me a
So let's
choice.
just pick some numbers to get more of a sense of what this looks like. If I'm plugging in -10, I don't want to plug in -10 into that without a calculator, but plugging it into the factored form is pretty nice. And in fact, what's anything squared going to be?
Well, yeah, that's always gonna be positive.
Always going to be positive. Fantastic. All right, here's another thing squared. -10 squared?
Positive.
-10 plus 3?
Negative.
So I have a positive divided by a positive times a negative. I'm pretty sure that's going to give me a negative. Okay?
That works.
So in -10 and on all of the numbers in this region, my y values, my outputs are down in the negative region. And I know that they are approaching where y is 0 from this direction. Vroom. And they're approaching the vertical asymptote in this direction. Vroom. I think the sound effect
That's
helps.
helping. That's helping
Yeah.
me. Yeah, thanks.
Okay, so far so good?
Sure.
Let's pick, oh gosh.
Ooh, how about a -1?
Let's plug in a -1 to see what's going on there. Okay, my numerator's going to be positive. We already talked about that. Anything squared down here is positive. It's really just this piece. -1 plus 3. That's positive, by golly. So when x is -1, I'm going to be in the positive zone. I know I'm going to be going through the intercept. I'm somewhere positive. I can't double back down because I'd be
No, you
crossing
can't.
the x-axis, and I have to get closer and closer and closer without ever touching that vertical asymptote. So now we can either be super sneaky, or we can plug in. If we wanted to see what's happening here, we could plug in a number like -2.5. But let's go back to that sneaky thing that you mentioned. What did you
Yeah,
mention?
let's use that double root idea. That must mean that I hit the x-axis and bounce right off.
Boing! Yeah, the double roots that we experience in the polynomial functions
Works the same way.
work the same way here with the rational.
That's amazing.
Isn't that neat? And if you wanted to convince yourself, if you plug in a -2.5, I think you'll quickly see that's positive, positive, positive. Sure enough,
Oh,
the
yeah.
y value's positive. That
That
didn't
works.
take too long to plug in numbers. All right, and we have one more zone to go very quickly here. Give me a number over here.
Let's
like
pick 1.
1, why not? Okay, so I have something positive on the top, 1 squared, 1 plus 3, positive. Hi, we're in positive zone again. And again, I think once you do enough of these, you can figure out what they look like.
That's kind of a funny looking one, but
It is a
yeah,
funny
that
looking.
happens sometimes.
But you know, even funny looking.
Saving up your money
Thanks,
for a
Stuart.
rainy
Fabulous.
day.